Good morning, afternoon, or evening, wherever and whenever you are. My name is Ben, and welcome to another Godot tutorial video. In this video, we're going to create a simple, well, actually, it's going to be a slightly more advanced finite state machine, and we're going to uh, program some AI for this little goblin right here, this little business goblin. The idea is when we move the mouse around on the screen, if the goblin can see the mouse, then it will follow the mouse. And if it can't see the mouse, then it will just kind of wander and bounce off the walls. So let's start by creating a new script. Over here on the left. Oh, you can see that I've got some projects set up right here. There will be a link in the description. I apparently can't use pinned comments anymore. YouTube actually went through and deleted all of my pinned comments. And I guess I'm not alone in this. I looked it up and there are other creators who have had their pinned comments deleted by YouTube. Not sure what's going on there. So there will be a link in the description. So now let's create a script. Yeah, so you can use that link to download this project at this point right here that we're at, so you can follow along. And we'll call this finite state machine. The finite state machine is well, let's rename that actually, because I prefer using lowercase now. Snake case for my scripts, but we'll give the class, we'll do class name finite state machine. Okay. And save, just like that. The finite state machine is just a way to run code on an object or entity or whatever, and have it only run certain bits of code at a time. So, and this can create states that your character is in. So you can have your chase state or your wander state. And while you're in the chase state, you won't run any code from the wander state. While you're in the wander state, you won't run any code from the chase state, and it separates out the logic and makes it a lot easier to handle. Plus, you can reuse these states on other objects. So let's say you have a different enemy that has a chase state, but it doesn't have a wander state. Maybe it just stops and is idle. You can reuse your chase state code. So it gives you reusable code as well. So the first thing we need to do is our finite state machine is going to be the class that handles the states, and its job is going to be switching. It's going to store the current state, and it's going to switch the states or change state. So let's give it the current state. We're going to do an export here, and we're going to export our state. And for now, we're not going to type it, but we eventually will type that. Without a type or initializer, fine, we'll type it as node for now, so it doesn't get mad at us. Okay. Now we're going to create a ready function, and in this ready function, we're going to call change state, and we'll change to the state. That just makes sure we initialize this first state right here. Now let's create that change state function. We'll say new state, and we'll type it as node for now. We're eventually going to change that to state. You know, a bunch of our code requires us to have the state class. So let's create it now. We'll come over here and we'll create a new script. And this script will be called state. Great. Come into it here and we'll give it a class name. State. And we're going to give it a couple functions. So we'll give it we're going to give it a signal as well. Let's give it a signal called state finished. This will just be kind of like a default, this state is done running signal. We'll create a function called enter state, and this will return void pass. We'll create another function called exit state. No, not tree, state. It will also return void, and we'll just pass. These are functions that when we create new states, they will inherit from this, and we will extend these functions. We'll add code to them based on what we want that state to do when it enters. Okay, let's come back to our finite state machine, and now we can type this as a state, and down here as well as state, because we want our finite state machine to deal with the state nodes. Okay, now we need to finish writing the change state logic. So we'll say if state is state, then we'll do state dot exit state. So this is the previous state, right? It's not the new state yet. So we're running the exit code for that state, but only if it's actually a state. If it's null, which could be possible, then it won't try and run that function. Now we'll say new state dot enter state. So now with a new state, we're going to call our enter state function. And then we'll actually update the state variable to reflect the new state. State equals a new state. Pretty simple. Okay, now we have the basics for our finite state machine. We can come back to our goblin here, and we can start creating the states. You can see I've already set up a shadow, collision shape, and everything, but we're going to need to create our finite state machine. So let's add a new node, and we can search finite state machine. And you can see because we gave our script a class name, it's showing up here, and we can add that right from there. So now we're going to need a couple states for our goblin. So let's start with the wander state. We're going to right click over here. We're going to create a new script. And this script is going to inherit from state. And we're going to call this enemy wander state. Create it. And you can see if we come into our enemy wander state, it extends state. We'll give it a class name. Enemy wander state. Like this. And let me check to make sure I'm actually got recording audio. Okay, I am. Okay, so we've got our enemy wander state. Now our state is going to need an actor. And this is going to be the thing that our state manipulates. So let's do an export variable for this. And we'll call this actor. It's going to need to be a so if we come into our business goblin here, we've got a script attached to it. So let's call this, let's see, what did I name it? I named it businessgoblin.gd. So we'll give it a class name. Business goblin, like that. And it's going to have a couple variables that we'll be using. So let's give it an export variable, max speed, set this equal to 40, and an export variable of acceleration. We'll set this equal to 50. Let's just do max speed, acceleration, that. Okay. So business goblin, although probably ideally we would want this to be just like a base enemy class like this. So we'll do that. We'll come back into our wander state, and the actor is going to be an enemy, just like that. And also in our wander state, we're going to need access to an animator. So var animator, and this will be an animated sprite 2D. Okay. And then lastly, well, that's good enough. Okay. This is our wander state. Yeah. We're actually going to need access to be able to determine if we can see the mouse. And for that, we'll need a raycast. So let's create a new raycast here. Raycast 2D. It will collide with layer 1, that's correct. And it will collide with bodies. And for now, we'll just set its target position to be it doesn't really matter. We'll just do 16 here, I guess. And what we want is for this to be constantly looking at the mouse's position. So let's add some code to our enemy here. This code right here is just for the sake of finding the mouse. So this is a little bit of like temporary code in order to make this scenario work. So we'll get access to our raycast by dragging this over and holding control and then dropping it. And then here we can say raycast dot target position equals get local mouse position. And now if we run the game, but we turn on visible collision shapes, enter state and base nil. Oh yeah, so come back into our goblin. We don't actually have a state set for our goblin. So come to our finite state machine and we need to give it a state. So let's find our wander state. Now we've got a state here, and if we come into here, we can select our wander state. So we click on the finite state machine, we give it a state of enemy wander state. And the rest of this should work now. Yeah, okay. And you can see the raycast is pointing towards the mouse, but if there's a wall in between, then it turns red. We can tell when the goblin can see the mouse. And that's the important thing here. Now we could make it come from like maybe the goblin's center, so it's not quite so like at the goblin's feet. And that might make more sense. You could even put it on the eyes if you're like, oh yeah, I want this to make perfect sense. The goblin can only see the mouse when it's coming from the eyes. I think I'm going to do it from the center. I think it makes more sense. Okay. So we have our raycast 2D. So our raycast 2D, our wander state is going to need access to that as well so that it can tell when the goblin is can see the mouse. So var raycast. Well, what should we call this? Vision cast. That sounds a lot fancier. Raycast 2D. Okay. So now these are the dependencies that this state has. These are the things that it needs access to in order to function. If it doesn't have those, it can't run its logic. So we're going to create a signal here. And we'll call it saw player. So when the goblin sees the player, or when this state sees the player. Well, we'll call it saw mouse. We'll call it saw player, even though it's just looking towards the mouse. Okay, so the first thing we want to do is we're going to write our enter state function. And inside of here, we're going to do set physics process true. So once we enter this state, we're going to turn on physics process. We're going to get our animator, and we're going to play the move function, or the move animation. You can see we've got a move and an idle. We're going to play the move. And then we're going to check. We're going to set our velocity, but we're going to only change the velocity if it's 0. So if actor.velocity is equal to vector2.0, then we'll say actor.velocity equals vector2.right.rotated rand f range 0 ow, and then times actor.max speed. Okay, so what am I doing here? I wrote a bunch of code. So we're setting the actor's velocity to be in a random direction, like 360 degrees. But this right here is actually 2 pi, so it's the same as 2 pi, which is 360 degrees in radians. And then we're multiplying it by the actor's max speed. So if the speed is set to 0 when we enter this state, it will start moving in a certain direction. Okay? Now we're going to write our exit state. I don't know why it's not giving us autocomplete for these, since we are extending state. Surprises me. But when we exit the state, we're going to set the physics process equal to false, just like this. Now, by default physics process, if you have a physics process function, which we will, physics process, if you have a physics process function, by default that node will turn it on right when it enters the scene. But we want it to be off by default. So what we're going to do is come in and create a ready function and just set it to false. This prevents our state from running its process, its physics process, unless it's the active state. So when we enter the state, it will set it to true, and when we exit the state, it will set it to false. So what is the physics process going to look like? Well, it's going to be pretty simple. We're going to set the animator .scale.x equal to negative sine actor velocity.x. And this is just going to flip the sprite to face the direction that we're moving in. But we want to make sure that it's never 0. So if animators.scale.x is equal to 0, then we're going to just set it to 1. Animator.scale.x equals 1. Okay. And then we need to actually move our goblin. And we want it to bounce off walls. So what we'll do is we'll say var collision equals actor.move and collide. So move and collide is kind of like move and slide, but it doesn't handle sliding. And then we can set this to be our actor.velocity times delta. Now, the other thing about move and collide is that you actually have to multiply your velocity by delta. With move and slide, it's done automatically. Once we've done this, we have a collision vector. So we can say if collision var bounce velocity equals actor dot velocity dot bounce collision dot get normal. So this, we're just calling the bounce function on our velocity, and we're passing in the collision normal to determine how to bounce, like what angle should we bounce at. And then we just set our velocity to be that, actor.velocity equals bounce velocity. This will handle bouncing. Okay, now if we run the game, this state should actually start working already. It says animator, oh yeah, we haven't set up any of our dependencies. So if we click on our enemy wander state here, you can see none of our dependencies are set up. So we're getting an error message that says animator is null, we can't find it. But first let's select our actor, then let's select our animator, and then let's select our vision cast. So we've given it all of the dependencies that it needs in order to function. And now you can see the goblin is moving around in the room and it bounces off the walls. Bounced a little bit funny right on that corner, but I guess it's fine. Oh, I guess it's because I have this, I have the collision shape for the goblin not set up as a square or a circle, but as a diamond. which just makes it slide a little bit better along edges when it's chasing the player. The other thing we'll want to do is set our world ordering to be Y sort enabled, so that theoretically the goblin should then be correctly drawn over the walls. Yeah, there we go. That looks better. Okay, but it's not chasing the mouse. We don't have our chase state. We also need to signal out when it can see the mouse. So if we come back into our goblin and then we click on our wander state again, we need some logic inside of the physics process that determines whether or not we can see the mouse. And we can do this pretty easily with our ray cast. So if vision cast dot is colliding, and then we'll just say not. So if it's not colliding, then we can emit our saw player signal. Saw player dot emit. And there we go. That's it. The wander state is complete. Now let's create our chase state. And this one's pretty simple as well. We'll create a new script. New script like this. We'll call it chase enemy chase state. This, and we'll come to our inherits here and make it inherit from state. Create the file, enemy chase state. Give it our class name. Enemy chase state. And it's going to need some dependencies as well. We'll give it an actor. And it's going to need an animator. And it's going to need a vision cast. That is not what I wanted to do. There we go. It's going to need a signal for when it loses the player. So lost player. Signal. There we go. And just like with the other one, we'll have a ready function that turns off the physics process. Set physics process false. And we'll have our enter state. Should probably be returning void on ready as well, just to be consistent. So in the enter state, we'll set the physics process to true. And then we'll play the move. In our exit state, we'll set the physics process to false. And then we'll create our physics process function. And inside of here, we're going to chase the player. And first, we'll do the same thing we did before with the other state, which is update the player's scale to be the direction that they're facing. So we'll do that. And we're actually doing negative because I should mention this because our goblin is facing to the left by default, so I had to throw a negative in front of that. Okay, then we'll say actor.velocity is equal to actor.velocity.move toward direction times actor.max speed, and then actor.acceleration times delta. And I'm running out of space here, so I'm going to maximize this so we can see all the code. So let's see. Direction not in scope. Oh yeah, I have to get the direction to the player. So var direction equals global position dot direction to local mouse position, or get local mouse position. Oh, what is the function? Is that it? Get local mouse position? Now all of a sudden my mind went blank. I can't think of what it is. I used it over here, didn't I? I use it right here. Get local mouse position. We have to do actor.get local mouse position. And it's because our state is a node, so it doesn't have access to that function. Actor.get local mouse position. And then we have to do actor.global position as well. Actor.global position. There we go. Which makes sense. We want our actor's position and the mouse's position relative to the actor. Okay, now we have our direction. So this function right here, it just moves our velocity toward this direction times our max speed. And then, so pointing towards the mouse. And then it moves towards that with an acceleration value times delta. And then we want to call move and slide. So we can just call move and slide. So move, let's see, actor dot move and slide. And then we can say if not vision cast dot is colliding, or if vision cast is colliding this time, lost player dot emit. Okay. So we move towards the player, and then if we can't see the player anymore, we emit lost player. And now this state is done as well. Now the thing about these states is there is a little bit of setup for them, obviously, but they're reusable. We can mix and match these states pretty easily. So now we're going to add our, I called it enemy chase state. We're going to add our enemy chase state. There we go. And we'll need to give it an actor and an animator and a vision cast. There we go. I love this new feature of Godot 4 where you can just export nodes instead of having to export a node path. It's so much better. It's a great quality of life feature. Okay, so now we need to handle our signals. So our wander state signals out when it's lost the player, and our enemy state signals out when it our wander state signals out when it's found the player. Yeah. And I guess we could call it found player. Saw player sounds like a horror movie. Found player. And our chase state signals out when it's lost the player. And we need to be able to do something with those. So what we're going to do is come into our goblin here. We're going to select our state machine, our wander state, and our chase state. Then I'm going to click. I was holding control to do that. I'm going to click and drag these over. And I'm going to press control again before I drop them. And that will give me access to all of them. Now, inside of the ready function, we can connect our states together. And the goblin itself is going to handle the logic of what state should switch to what state, because, that could be different. You might have an enemy that has a chase state, but when it loses the player, instead of wandering, you want it to do something else. And so that enemy needs to handle that logic. So inside of here, we'll say, this is where things get a little bit fun because of Godot 4. We can say enemy wander state dot found player. Oh, and we're not getting autocomplete, but we can fix that just by simply casting these. So we can say as enemy wander state and as enemy chase state, like that. And then down here we'll get code completion. So found player dot connect. We're going to connect it to our finite state machine. I'm just going to call it FSM here for short. So FSM dot change state, and we want to do as finite state machine, so we get autocomplete as well. Change state. So this is the function, but we're not calling this function. We actually don't want those parentheses around it, but it does take an argument, so we have to pass in that argument, and the way you do that is with the bind function. So dot bind, and then we pass in enemy chase state. What will happen is we're connecting the enemy wander state's found player signal to the change state function on our finite state machine, so it'll change to the chase state. This just tells our code to say, when the wander state finds the player, change to the chase state. Pretty simple. Enemy chase state dot lost player connect finite state machine dot change state, and then of course we want to bind our argument, which is going to be enemy wander state. So when we've lost the player, switch back to the wander state. And let's run the game and see if our code works or if we have errors. So it's chasing the mouse. And I can tell that it's not working because it's not moving towards the mouse correctly. And this probably has to do with how I'm getting the mouse position. So I've messed up my math there. But it is in the chase state. You can see it is chasing a point. It's just the wrong point. Like when I move the mouse, it does try to change. But if it can't see the mouse, then it switches back to this wander state where it just kind of wanders around and bounces off of walls. But the minute it can see the mouse, it chases towards it. So we've got to fix the way that we're getting the mouse's position so that we're actually getting the correct position, and then this will work. Let's come into our chase state. Okay, so I think what is happening, if I'm thinking about this correctly, is that get local mouse position is already the position relative to the actor, because it's actor.get local mouse position, but I'm actually trying to move towards it, getting a direction towards it. So it's from our relative position. So I think if we just set this to vector 2.0.direction 2, it will actually fix it. Yeah, that was the problem. Now you can see it chases the mouse, tries to go towards it, but then if it can't see the mouse, then it just wanders. I do want the wander state to accelerate, because if it's moving really slowly and it switches to the wander state, then it doesn't accelerate back up. So let's come back into the wander state, and what we'll say is during the physics process, we'll say velocity, let's see, actor.velocity equals velocity actor.velocity.move toward, and then we'll do actor.velocity.normalized times actor.max speed. And then we'll move towards it with actor.acceleration times delta. This should just make it accelerate when it's in the wander state until it reaches its max speed. So you can see now, if it enters the wander state, even if it's going kind of slow, it will accelerate back up to its max speed. Can't see us. Now it can. Now it can't. And it does work. Okay. We might up the acceleration just a bit. It's pretty slow in how it accelerates. But you can see how powerful this system could be with reusing your states, since your states themselves don't know which state they're going to switch to when they're done. They just signal out when they've completed some task, right? oh, I lost the player, I'm going to signal out and let um, whatever actor I'm working with know that. And then we can just connect right to those signals and react appropriately. So that's going to be it for this tutorial. I hope you enjoyed it. Thank you so much for watching. I'm doing a sell on my 2 Godot courses actually. I have a Godot 4 course and I have a Godot long-term support course. The Godot long-term support version is a turn-based course. It's currently on sale. And then my 1-bit Godot 4 course is also on sale right now. So there'll be a link in the description if you're interested in learning more about those. Thank you all so much for the support, and I will talk to you all later.